Can you see my slide now? It's okay?
Good morning, everyone. I'm Véronique Boucher. I'm the director for the Science and Innovation Department here at WMO, and it's my pleasure to welcome you to the panel on AI for weather forecasting, closing the digital divide with AI. I will be handing over the chairing of the session to Dr. Florence Rabier, the Director General for the European Center for Medium Range Weather Forecast. And I do want to highlight a few of the contribution that ECMWF has done regarding AI in leading us forward over the past 3 years, developing quite quickly the AIFS, Anemoy, and Forecast in the Box that have led to many of the centers among ourselves to move forward in this particular area that is advancing really quickly. So I think we are in good hands with this session, and I'll hand it over to you, Florence.
Thank you very much, Veronique. And it's really a privilege to have been invited to chair this session, which is such an important session at this extraordinary Congress. So over the next hour and a half, we will talk about artificial intelligence, which is a very timely topic. And within this topic, we'll talk about collaboration in the context of AI. So I'm sure there's no need to remind you that AI and machine learning have taken our community by storm in the last few years. And initially, research and innovation, I think it's fair to say that it was mainly done by major giant tech companies and developed countries. But since 2022, we have seen these giant techs like Huawei, NVIDIA, Google DeepMind, Microsoft, developing machine learning models for weather forecasts with tremendous results. So these developments have been catalyzed by the availability of high quality, openly available data sets, such as the Copernicus reanalysis, and also advances in deep learning architecture. But then there was also, very importantly, the realization that producing these models, running them to produce some forecasts was cheaper in terms of computational cost. It came with a much cheaper computational cost rather than traditional methods. But WMO members were fast to react, and a couple of years ago, it was in May 2023, WMO Region 6 led an event on artificial intelligence and support for early warning for all initiative here during Congress. It was moderated by Roar Skalin here, and representatives from the tech companies and from different member states and ECMWF as well gave presentations. But it's true that weather services have been quite quick to embrace this, and organizations like mine, but because they've started already, machine learning have been developed and started to be implemented in operations. So Veronique reminded that we have implemented our first model, AIFS, in both deterministic and ensemble mode, but we're not the only ones. There are other med services who have already implemented machine learning models in operations or are in the process of doing so. But individual efforts are great, but it's really the collaboration that truly makes us stronger as a community. And it is that same spirit of collaboration which has since the beginning defined meteorology, which is now extending to machine learning in this new area of work. Sharing of data, sharing of code, it's all happening as we speak. So together with our member states and partners, we've developed this framework called NMHSs, which allows the training and running of machine learning models. But this is just one example of collaborative initiative that is taking place in the field. It's also essential that to ensure that the emergence of AI and machine learning does not widen the technological gap among WMO members of varying development levels, and closing this gap should now be a priority area for all of us. So this panel represents some examples of collaborative AI technology developments projects that WMO is advancing with NMHSs, highlighting efforts to promote inclusivity and capacity building. But collaboration is needed not only between members, but also across sectors, because we've seen that AI innovation was partly driven by the private sector, but also very importantly by academia. So this is why discussions on advancing AI across the entire industry recently took place, including the WMO AI Conference in September in Abu Dhabi, and the Meteorological Forum at the World Artificial Intelligence Conference in July in Shanghai. So the outcomes from these events will be introduced in this panel too. We'll also discuss the opportunities and concerns associated with AI technology. And eventually, the goal is to advance together to explore the strategic direction for WMO and its members in this rapidly evolving field, which will definitely shape the future and activity of our community for the foreseeable future. So with this short introduction, I will now hand over to the first project that will be presented. So this will present the outcomes of the Malawi project led by Met Norway in collaboration with the Department of Climate Change and Meteorological Services of Malawi and together with ECMWF. So it aims to pilot the use of AI to enhance weather prediction capabilities and strengthen early warning systems in Malawi by deploying the high-resolution AI model BRIS and the concept of forecast in a box. So this project is recognized as WMO Integrated Processing and Prediction System WIPS pilot project funded by CRUISE. The presenters are Dr. Roar Skalin, Director General of the Norwegian Meteorological Institute and Permanent Representative of Norway at WMO, and Dr. Lucy Mtilatila, Director of Department of Climate Change and Meteorological Services in Malawi. Over to you for 20 minutes.
Thank you very much, Florence, and thanks for the opportunity for Lucy and myself to present some of the lessons from the AI for Early Warnings for All in Malawi pilot project. As Florence said, this project is supported by CRUISE and WMO, and ECMWF has been an important partner in implementing the project. Clearly, it is not me and Lucy that have done the work. You will see some of the team members in the presentation, and you can meet 3 of them in the booth outside the room, and they will be able to demonstrate AI forecasting and answer any questions you have. Next one, please. So the main goal of this project is straightforward: to deploy and evaluate AI weather prediction in Malawi and explore how AI can strengthen early warning capabilities. Another goal was to be able to present some results here today, which we're doing now. The project had a kickoff earlier this year with really getting to going in May, so the team has worked very fast on this. Next one, please. So what is artificial intelligence-based weather prediction, AIWP, or as it is sometimes also referred to, data-driven forecasting? In traditional numerical weather prediction, we model the physics of the atmosphere by mathematical equations and solve them numerically on supercomputers. In AIWP, the model learns statistical relationships directly from the data, which could be reanalysis, satellite observations, and WP output, etc. And they use this knowledge to predict the future weather states. You could also foresee a combination of NWP and AIWP, which is sometimes referred to as hybrid AIWP, which combines physical models with AI components, for instance, for bias correction, for downscaling, or emulation of some of the physical processes. But today, we will talk about a complete AIWP system. And I now give the floor to Lucy to give you some insight into how we have worked to implement it in Malawi.
Thank you very much, Ro, and thank you very much also, Secretariat, for giving us this opportunity to share with the wider community on how AI is being piloted in Malawi. I would like also to recognize the support that we got from CRUISE to give us an opportunity to test this AI in our setup. Can we go to the next slide, please? The relationship that we have with METNO is a long outstanding one. It started about 5 years ago. And this partnership is about peer-to-peer kind of relationship where we've been having that privilege of learning from METNO in various aspects, including forecasting. So when this idea of AI came in, it was very quick to adopt it and see how we can pilot it in Malawi. By peer-to-peer, what it means is that we are given an opportunity to interact with the experts, with the researchers, with IT experts, to work together as a team. In that way, we are really assured of the sustainability of the expertise that we are learning. So this learning is in twofold. It's physical as well as also we have some virtual meetings, which we regularly meet And through that, we've been learning quite a lot, and we believe that the outcomes of this, including the AI itself, will support the work that we are doing in terms of climate services in Malawi. So my presentation is basically to share with you the prospects and also our energy that we are feeling on how this AI can support the work that we are doing in Malawi. Can we go to the next slide, please? Thank you. So yes, we are getting a tool in a box, which is technology. It's also a weather prediction tool. But as we are exploring it, we are also seeing some advantages that we feel they can support the work that we are doing. So through this tool, as we are piloting it already, we are seeing improvement of the forecast that it is able to generate, especially in terms of accuracy. Of course, there are some areas that we still have to work upon, but at least the first initial results are showing some positives. As you've already heard, that this is just a short, we've just piloted since May, but it's the work in progress. But already we are seeing that even the timeliness on how we produce the forecast is very quick. And of course, we are benefiting on the capacity as well, on how the technology aspects, as well as how to use it. And we are seeing it is also as a potential of being integrated into other services that we provide in Malawi. Can we go to next? And just to add on, as we're saying that it's a tool that is very quick when you are producing the products, which is giving us ample time now to see how we can explore these results into specialized sectors. So we are seeing that potential of upscaling it and including a impact-based focus from this tool. Building on the national framework for water and climate services that was launched last year, we are looking at this as one way of trying to integrate this into specific sectors, including health, in future energy. So already we are planning ahead, looking at the way it is giving us some positive results right now. And at the same time, it has a potential of automating the work that we are doing. So in other words, it's something that we feel that it can lessen the work on the daily tasks that we do. In that way, for us focusing more on the impacts, as well as also it has a potential that can strengthen the early warning. Or in this, we are also seeing that it's something that is interactive. It is easy to integrate with other systems as well. So we are looking forward to this, and we are seeing that synergy that it can help to support the work that we do with easy and also cheap resources. Can we go to the next? So for us to adopt this, yes, there are steps that we need to follow. Right now, we are in the process of continuing to verify the products that we are generating. Of course, what we want to see is to see something that is filling the gap, not necessarily just adopting since it's there, no, but it's something that we feel it will fill the gaps that are existing. So we are doing that systematically, the verification with the NWP. We have the models that we also run, so we are working them concurrently. But the other aspect is we are still looking forward to the capacity building since we've just started, but there are a lot of things that we still need to learn and understand on how this tool works. So this is work in progress, and we are looking forward to more capacity on this. Of course, more importantly is the issue of sustainability. So we don't want to start something that will not finish. So this tool will after the verification and we see that it is really giving the results that are anticipated, we are looking forward now to integrate it into other tools and impact-based forecast, for example, into early warning, and at the same time supporting the work that we do. Thank you so much. Over to you.
Thank you, Lucy. Can we have the next slide, please? So I'll go now into some details, not very much, but some details on the components that we have used in this project. And Florence mentioned Forecast in a Box. Forecast in a Box is a tool that is developed by ECMWF with funding from the Destination Earth program of the European Union. It's a very flexible tool that takes care of all the parts of the production chain not done by the model itself. So it prepared the initial conditions, it runs the model, and you can configure it to create user products that you would like and also to visualize the products. It can be deployed anywhere from a laptop to a supercomputer. It's easy to run, and it's not tailored to one single model. You can use any AI model of your choice within Forecast in a Box. And as I said, you can tailor your own products. It's completely open source, so you can download it and get it for free and use it yourself. It needs some further development before it's ready for downloading. I'll come back to that, but it seems to be a very flexible tool. And then the next one. The model that we have used in this project is called BRIS. It's the model developed by Met Norway, based on the global AIFS model from ECMWF. And it uses this framework that Florence referred to, NMHSs, which is a framework for AI modeling developed by ECMWF and European countries. What is a bit special with BRIS is that it is both a global and a regional model. It is truly global and it learns from the whole globe, but we have a stretched grid, which means that we can have increased or higher resolution in one region. It forecasts what you expect: clouds, precipitation, temperature, winds, etc. And at Met Norway, we have been running it daily since November 2024, so almost 1 year. Of course, continuously improving the model and adding new features. And it's now also an ensemble version of BRIS. Next one. So in Malawi, we have set up BRIS and Forecast in a Box for the domain of Malawi, which you can see in this picture. And we have tried to run it on several different infrastructures. I'll get a bit back to that. The model is running based on downscaling global data as input to BRIS. And the prototype is now ready for deployment at DCCMS. Next one. So here are two of the infrastructures that we have been using. The Met Norway cloud infrastructure, where we can run this model on one NVIDIA GPU with a runtime of 2 minutes for a 10-day forecast. Then we have a much cheaper piece of hardware, the box that you can see there, and a Mac Studio box costs about $5,000. And here you can run a 10-day forecast on 19 minutes. We will also test it on other boxes with only one GPU, and we believe that using an NVIDIA GPU, we can get the runtime further down. But still, 19 minutes for a 10-day forecast on one GPU, I think is quite impressive. And also when you take the cost of that box into consideration. Next one, please. Okay, so what are the results of this project? We have only done this, as you've heard, for a few months. On the normal condition, it seems to be well forecasted, comparable to all the other models we have for Malawi. We need to improve the forecasting of extremes. You see one track there with the cyclone Jude from March this year. We do have quite good ideas on how to do that. We have currently not trained on similar situations. So what we want to do is to train the model either on the data we have available for Malawi or other domains where we have similar cyclones. Next one, please. So what is the main lesson learned in the project? Close collaboration between all the partners is crucial. So we've had in this project forecasters, IT developers, scientists, social scientists, and we have had teams from both ECMWF, DCCMS, and Met Norway, and that is essential for implementing such a project and to get these continuous improvements. Next one, some other lessons. We have seen that the forecast in a box makes AI weather prediction easily accessible, easy to set up, easy to run. The model we have used showed promising results, but as I said, it needs to be improved for extreme events, and we need to continue the systematic evaluation of how the model performs. And now, when DCCMS will start using it, it will, of course, be very valuable for us to get the feedback and assessments from their daily usage of the model. And then one very important lesson to all of us. A collaborative effort on data is needed for future iteration and for starting using AI-WP. We need good data for verification of the model, and we need good data for training of the model. So that's absolutely essential that the whole community contributes to an effort on data. Finally, or almost finally, we want to continue the development and the capacity building with DCCMS. And we would like very much to develop educational material on AI-WP together with the community and make forecast in a box and Breeze production ready and more generally available. So pack it and make it easy for all of you to download, install and run. And explore, as I said, the possibilities and benefits of including local data in the training of the model. And also assess how different Breeze configuration affects the forecast quality and runtime. So that could be different horizontal resolutions, different infrastructure configurations, and also, of course, using Breeze in ensemble mode. Okay, so now Lucy and I have spent 16 minutes explaining this project to you. I'll now give the floor to some of the team members, and they will be able to explain the whole project in 2 minutes. So let's see if we can have a video running.
Hi there, we are part of the team from Met Norway in the Artificial Intelligence for Early Warning for All pilot project. I'm the project manager.
And I am one of the developers who work on the technical solutions together with ECMWF.
We are excited to tell you about all the tools that fit into this little box. It contains the AI weather model, but also data processing, visualization, and other parts of the production chain.
With a box like this, anyone can easily generate an AI weather forecast for any place in the world with the infrastructure of their choice. It is easy to set up and easy to use.
It generates weather forecasts much faster than with traditional models, meaning improved early warning of severe events. For now, we are focusing on Malawi, who will tell us about their experience.
On behalf of DCCMS, I would like to sincerely thank Met Norway and the World Meteorological Organization for your continued trust and support in enhancing the Met Malawi's capabilities in weather forecasting. Being the first country to be a part of this project, the AI in Forecasting project, It's a great honor to us, and it's a milestone in strengthening our capabilities in providing accurate as well as timely weather forecasting. We are therefore very much excited to be a part of this collaboration, and we look forward to learning throughout the whole initiative. I'm Tabiwa Kuramudu, a weather forecaster at the Department of Climate Change and Meteorological Services in Malawi. Thank you.
Thank you to the team. And now it's my pleasure, Lucy, to give you the box. The forecasting is inside, and you can run it as often as you like.
Thank you.
Okay. Thank you very much, Ror, Lucy, and the whole team for this excellent presentation. So I suggest that we go through the whole presentations and we'll take questions all at the end of the session. So next, we're going to talk about another partnership about MAZU. It's the introduction of the multi-hazard alert zero gap and universal, so MAZU. It's an AI-powered early warning system developed by the China Meteorological Administration, which was officially launched during the 2025 World Artificial Intelligence Conference. It has been actively used for collaborating with several developing countries through this initiative and co-developed cloud-based early warning systems. So one of them is Ethiopia, and we will have live link with Ethiopia as well. So the presenters are Mr. Zhang Wei, a Deputy General Manager of Huafeng Group under the China Meteorological Administration, and Mr. Leta Bekele-Gudina, key expert at the Ethiopian Meteorological Institute, who is online. Over to you.
Fisherman. Tragically, she gave her life in a rescue.
My slides, please. Thank you, Chair.
This centuries-spanning guardianship inspires CMA to bring MAZU, an AI-powered solution, to the United
Next slide, please. Thank you. Finally, thank you, Chair. Thank you for a wonderful introduction. I didn't even know I was this impressive. Thank you. And distinguished Secretary General WMO, Professor Celeste Solo, and distinguished guests, ladies and gentlemen. And it's a great honor to stand here and share with all of you China's efforts and practice in responding to global climate challenge and the MAZU, a partnership for early warning for all, empowered by AI. I also would like to extend my sincere gratitude to WMO for provide such a wonderful and authoritative platform. So first of all, we have prepared a video, for everyone gain some intuitive understanding of MAZU first, please. It's about 3 minutes, less than 3 minutes. Yes, the video, please. Thank you.
China's southeast coast lived a legendary woman, Lin Monyang. Born in 960 AD, she forecast storms and braved raging seas to safeguard fishermen. Tragically, she gave her life in a rescue. Today, that guardianship is carried forward by modern technology and a shared sense of responsibility. She is revered as MAZU, recognized by UNESCO as an intangible cultural heritage of the ocean. This centuries-spanning guardianship inspires CMA to bring MAZU, an AI-powered solution, to the United Nations Early Warnings for All initiative. MAZU is a platform we share with global partners to close early warning gaps and tackle climate risks together. MAZU connects 4 pillars of the Early Warnings for All initiative, creating a seamless loop from warning to action. First, AI integrates data to answer, where is the risk? Next, AI-powered models accurately predict when will the risk arrive. Then, AI technology delivers targeted early warnings to those who need it most. Finally, AI provides clear, actionable guidance on what we should do. We believe cloud-based, AI-powered services are the most effective way to close the warning gaps, and we remain committed to co-developing tailored tools with partner nations. Mazu is an action-oriented solution with a flexible collaboration model. From consensus to action, we are honored to have worked with multiple partners to deploy cloud-based early warning platforms locally and drive regional AI innovation.
We more focused on AI cooperation. For example, Mazu.
These tools is very important.
We are looking forward to have more cooperations.
Looking ahead, Mazu will expand into environment, agriculture, transportation, and more to deliver risk and impact-based AI services. We sincerely invite all partners under the WMO framework to join us in building a global AI-powered early warning network.
Thank you. Thank you very much for watching. Thank you. And thank you. Get back to my class, please. Yep. So it doesn't work. So anyway, yeah, finally. So as introduced in the video, Mazu platform developed by CEMA closely aligns to the 4 pillars of UN's early warning for all initiatives and is fully empowered by AI already. And as an intelligent and configurable platform, the clicker doesn't work well. Okay, thank you. So the Mazu platform facilitates the integration of monitoring weather forecasting early warning functions through a modular cloud plus and open technology architecture. So we also provide a plug and play scalable toolboxes to enable users to achieve customizations. And this platform can also integrate with a diverse data source, different weather forecast early warning models globally. So, next please. Based on the different technology foundations and the types of disasters in countries, we have designed multiple types of Mazu platform already. And if you need hardware-free and rapid deployment, the cloud version can be directly via internet access. And there's no need of on-site installation and maintenance. And if you need the possibility, the integrated devices, including the hardware and software, can be provided to support the local data receiving and processing. And if you seek independent ownership, the Ultra version can provide you a full technology transfer and enhance AI capabilities and private cloud deployment. And there's another version called Urban version, and this one can deliver terminal intelligent multi-header terminals for the users to enable the refined risk assessments. So next one, please. Yeah, as integrated weather forecasting platform, the Mazu platform, there are different several AI weather model developed by CEMA has equipped here with the different functions. And the first one is a low forecasting weather model. AI model is able to generate echo weather radar data product with a resolution of 1 kilometers and for the 0 to 3 hours. The second one is a short-term AI weather forecasting model. It's capable of producing a global forecast of 69K meteorological elements for the next 15 days with a resolution of 25 kilometers. And the third one is a climate prediction AI model. That one is quite useful to produce 60-day ahead global daily weather products, including 15K climate elements. Another one, we also developed another model to produce the solar, wind, and space weather forecasting products. Next one, please. And currently, there is very significant in CMA to develop it's called Fengyuan. It's kind of an end-to-end AI weather forecasting module, and that can integrate the weather forecasting module and the data assimilation module. And by using data assimilation module, it can generate a high precision analysis field for the data forecasting module. And on the other hand, data forecasting module can also feed back a high accurate background field, for the data assimilation, where the alternative for calculations. And this one will be made on open source soon on GitHub. And by using one GPU, single card, in your personal computer, you can complete a global forecast for 10 days with a resolution of 0.25 degrees. And next one, please. And in the early warning area, currently by using the intelligent positioning technology, the early warning information can reach the affected populations at a faster speed than ever before. And in China, currently we developed a meteorological text generation large language model. That one is, based on the technology of LLM, fine-tuning, and distillation, also integrated with the domain-specific meteorological knowledges. After deep learning of relevant information and regulations, this model can be very helpful to transform a great number of weather forecasts into impact and risk insights. And of course, helps users in drafting relevant disaster prevention and mitigation regulations and development plans. Next one, please. So, under the UN's Early Warning for All initiative and supported by WMO, we have Mazu platform have been deployed in several countries already. Like in Solomon Island, we improved the terminals for cloud versions in 9 different islands, and in Ethiopia, currently we are jointly developing the basic version. You keep with the integrated localized the short-term weather forecasting AI model with the downscaling technology, as well as agriculture weather forecasting and monitoring products. And in Pakistan, we have invited 3 experts from PMD to China for 3 weeks jointly R&D program. And after that, we dispatched our expert team to PMD, to jointly deploy this pro version equipped with customized early warning models for the glacial lake outburst floods. And basically, the cloud and the basic version are pilot projects and can be upgradable to satisfy more needs. Next one, please. So, international cooperation is very significant for Early Warning for All initiative. And in terms of technology openness, the open architecture of Mother platform enables the integration of diverse data resources and different weather forecast and early warning models from CMA and from users themselves over the world. And next one, please. And in terms of the data openness, the CMA has released the global climate data sets, including 6 categories, such as global surface and upper air observation data sets. And the earliest data can date back to 176 years ago. Next one, please. And in terms of cooperation terms, CMA will provide 50 long-term visiting scholarship and 2,000 short-term training opportunities and 100-degree scholarship in the next 3 years. So we are looking forward to jointly developing and efficiently deploying different versions of a Mazu platform, allowing global users to share the latest meteorological technology achievements and service products of China. Next one, please. So I think Mazu is more than an AI technology platform. She's guiding our meteorological safety. She's a partner in UN's Early Warning for All initiative. And she's also a global cooperation bridge, narrowing the universal early warning gaps. And that's her phone number and email address. We are looking forward to working together and making more contributions to Early Warning for All initiative for the sake of every community and every life. Thank you very much for your attention. Thank you.
Mr. Bekele, over to you.
Okay. Sorry. Hello, everyone. My name is Lata Bakala from Ethiopia Meteorology Institute. Today I present the AI in weather and climate and application of WMC Beijing product and a customized cloud-based early warning supportive system for Ethiopia. My outline is the introduction and the collaboration of EMI and CMA, cloud-based early warning in Ethiopia. As we know, climate-related hazard is affecting in different global features, and over Ethiopia also the major or very effect in our country is drought and rainfall, heavy rainfall, that is flood, and some of landslide. In the secondly, disaster outbreak because of the linkage of climate stresses. The figure we're showing is the current situation is not far. In 2022, the drought in southern Ethiopia and the flood happening in 2023 over the Somali area in the eastern parts of the country. The weather and the climate forecasts are vital for agriculture and the water and health parts also, disaster management. According to that, the AI transformation forecasting is faster data driving and localized the prediction when we use this AI tools to address early and to fill the gap between the potential and the practices. The collaboration of China Meteorology Administration and Ethiopia Meteorology Institute is starting from long year, and EMI is closely work with NMHS and different institutions. Currently, closely work on this development of early warning, cloud-based early warning system and different activity to collaborate with CMA. The development of this cloud-based early warning system for Ethiopia is, as a region, just focused and localized the information from the global and incorporate with a local system. This early warning system is essential for saving lives and reducing damage by giving timely alert about the weather and the climate. Currently, WMO also focus on this early warning system. This cloud-based early warning system, they have four parts: monitoring part, forecast part, early warning part, and numerical weather prediction part. Under that numerical weather prediction part, currently add this AI model product. This AI model product is very crucial and very important to addressing timely for before affecting the community or the area, to address information and to save the lives. This is very important for us. Overall, this the development of cloud-based early warning system and the collaboration EMI and same way is very important, and integrating this AI into Ethiopian weather and climate is deliver fast, smart, more reliable forecast supporting resiliency and sustainability. This is one of the exemplary and very essential to support our service by developing this cloud early warning system for Ethiopia by CMA. The next plan to jointly develop this pro version of multi-hazard alert zero gap, which will be equipped by this fungal AI, weather forecasting and model downscaling technology, and agricultural weather monitoring and forecasting products. This is very crucial, and we are going to forward according to this. I think very important thing is what I share. This is what we have. Thank you.
Thank you very much to both of you for another excellent demonstration of how people can work together to develop this AI and apply it in different contexts. So thank you very much. Now, the final presentation is not about an example, it's more about conclusions. It's about this WMO AI conference, which was held from the 9th to the 11th of September in Abu Dhabi in UAE. and the conference was hosted by the National Center of Meteorology of the United Arab Emirates. It brought together 50 international experts from NMHS, ECMWF, academia, and the private sector, and it aimed to discuss the opportunities to build an AI ecosystem for the global good. So we are going to have a presentation by 3 presenters. I don't need to introduce them much because they are talking quite often in this context. So Owen Moran, Michel Jean, and Ian Lisk, over to you to present the conclusions of this conference. Thank you.
Thank you very much, Florence. Just before we start, I think, words that sum up where we are as a community with AI, it is an absolute game changer. Okay, I think that is something that we as the WMO have to be completely aware of, that this changes the game massively. Second thing I just want to say before I go through the presentation is that I mentioned yesterday when we were going through the tech regs that the Services Commission's going to be producing this guide to go through Circon 4, and we're going to have to do that in 12 months. The pace at which we have to do our work if we're to engage with this opportunity is unprecedented in our community, and that's something else I think that we just would really do well to remember. If we spend 4 years coming up with standards, recommended practices, ways of working, we're going to miss the boat, my friends. So I just wanted to say that before I start on the presentation. So next slide, please. So as Florence said, we all got together in early September, 40 degrees in Abu Dhabi outside, about 10 degrees inside with the air conditioning. A couple of us had thermal shocks going from the hot to the cold. Don't know if AI can do that as well. What I'm going to summarise very, very quickly is the primary outcomes of that conference. I think the most important thing to say is that it was a real get-together of our traditional communities, NMHSs, but also fantastic representation from research and academia, and also the private sector. Private sector, both in terms of HMEI as being our traditional body that we deal with from a WMO perspective in our relationship with the private sector, but also the likes of Google and Microsoft and startups such as Brightband. And for me, being there for that week, both in terms of what we talked about in the 3 days of discussions, but inevitably what we talked about in the sidelines was the very frank and open discussions and cooperation that that conference actually enabled. So for me, above everything else, was a very honest set of conversations that took place. Next slide, please. So there's the headline statement: AI will form an integral part of the future of weather, climate and hydrological prediction. Florence, I was with Florian Pappenberg in London last week. We were talking about the pace of change once again. This is all happening now. In many, many cases, it's already happened. And the way in which we do the forecasting of weather from a modelling perspective will be completely different in less than 5 years. Okay, so that's a conversation both coming out of the workshop, but also follow-up conversations since. So the focus was very much on the collaboration, which I've talked about. There will be significant implications for the delivery of services. I think a couple of the presentations, certainly from our Chinese colleagues just now, talked about first guess warnings products. So the AI actually producing the warning as a first guess. That is a fundamental change to the way in which we have to train our staff in the future in terms of the competencies that they will have. I can sit here as the Services Commission President and say there will still be a role for the human either in or over that loop. Whatever happens, when a warning goes out the building, it needs human eyes on it. It always will need human eyes on it. So just an assurance there that this isn't going to take over the role of all of our forecasters and meteorologists of the future. Lots of conversation, and I'm sure Michelle will say more on this in a few moments' time about the data requirements, observations. If you've got rubbish going in, you're going to get rubbish going out. So lots of conversations on what those data and observation requirements of the future are likely to be. This talks to GBON, Global Basic Observing Network, but it also captures non-traditional sources of data information as well. And again, I would imagine Michelle might wish to say a few more words on that. And of course, the whole modelling side of it as well. And we've seen many, many examples of that just now. Establishing trust. And that for me was a big, big take home from Abu Dhabi. Once again, these frank and open discussions with our friends in the private sector, an absolute understanding. And this goes back to the technical regulations conversation of yesterday, that the warnings area is the absolute responsibility of the authoritative voice at the national level, right? That there is no debate about that, and complete and utter agreement coming out of Abu Dhabi from that. Huge capacity development opportunities, but also challenges, but very much a focus. We've seen these fantastic examples this morning of various initiatives, Solomon Islands, Malawi, Ethiopia. This is fantastic to see, but also the governance frameworks. And we'll say a little bit more about that in a moment. Next slide, please. So affirmed intentions, AI is here to stay. Its complementary role to existing physics-based models, but I think the balance between physics and into AI clearly is going to change very, very quickly. I've said the next 5 years. Total respect for the authoritative role of NMHSs in producing official warnings, I've just said. Let's keep the dialogue going. Abu Dhabi happened. We've got to maintain that momentum. Ongoing investment in capacity and the necessary training, changes in competencies I've mentioned. Common principles to guide responsible and effective integration of AI as well, and to come up with sustainable solutions. But one of the things we have to be very careful about is the ethical considerations and obviously security implications as well. The more of this stuff we put open source and out there, we do still have to be very, very careful about the ethical and the security implications of doing it. We can't just do it and say everything's going to be fine. Next slide, please. And then we've got the breakout sessions, as you can see. We had several of these. I'm not going to read these out line by line. The presentation is available on the website for you to go through in your own time. But once again, the same themes coming up: public-private partnership, trust, capacity development, and let's do more of these pilot projects to trial, localized national applications of AI capabilities, and then scale them up and share them more widely around the world. Next slide. So next steps. So really good in-depth engagement at the conference. The urgency, we haven't got time to think very long about this. The time for action is now. Agility I've talked about already. Openness and trust, fundamentally important, and to reflect the type of flexible mechanisms discussed to advance in a rapidly changing environment with adequate and agile governance. So again, the governance side of this, we can't just ignore it. We're going to have to put some frameworks in place as well. We're looking at this from Michelle's perspective in the WIPs, the WMO integrated processing systems on Michelle's infrastructure side of things. We're all ready to actually address the guidelines required to do this. Verification and validation. We saw the slide that said more accurate forecasts. Well, it's easy to say, but we've got to be able to provide the evidence that actually we're validating, verifying. Is it more accurate? Is it consistent? Is it reliable? All of these things are fundamentally important as we move forward with these new technologies as well. And again, capacity development and training. Now, WMO is creating a joint advisory group on AI. It will be co-chaired by Michelle as the president of the Infrastructure Commission and Amanda Lynch as the chair of the research board. Services Commission will be represented on that group. And will obviously be a very loud voice on it. But what I'd like to do is to leave it at that. Those are the main outcomes. Please look at the presentation online. Questions will come later. Without further ado, I'll hand it back to the chair and then maybe over to Michelle after that. Thank you very much.
So thank you, Chair. Thank you, Ian, for this excellent overview. If we can leave the presentation there and maybe go to slide 3. What I will do is that I will quickly make a few points on each of the slides that Ian has presented there. I'll do that relatively quickly because I do want to leave enough time for members to actually contribute and ask a question. On that particular slide, on slide 3, Ian has spoken at length with respect to the data. I'll make 2 comments there. We talk about prediction, but it's not only about prediction. It's about the full value chain, essentially. It has implication everywhere from, observing systems all the way down to the service production and decision-making systems. 2 areas where I would like to stress maybe a couple of points. We talked yesterday in the context of the early warning systems tech regs. We made the mention of cataloging, the cataloging of warning. You will recall that you members have approved moving forward with the cataloging of warning back a decade ago. And I had the pleasure to actually chair the initial sets of meetings to set the basis for that. But the whole vision back then was to actually organize the data linked to warning in a way that would allow the training of model for linking the warning with the impacts, actually, be it at the regional, national, or global level. So this is really critical. So it's not only about the forecast, it's about, all the byproduct associated with that, non-traditional in a certain way, non-traditional data. The other is in the context of moving toward sub-seasonal to seasonal and AI for climate prediction. As the chair of the task team on the climate infrastructure, it's apparent that we have thousands of boxes of climate records that have not been digitized yet. And a lot of the increase in the quality of the long-range forecast and the climate prediction is probably hidden in those boxes. So we have a lot of work to do. It's not only about, running forward with, the exciting development and the possibility to develop new services, but those new services will be as good as the data. And a lot of the data to improve long-range forecast is in those boxes of paper archive. So keep that in mind. Next slide, please. On this one, again, Ian did a really good job at going through that. I will insist on the common principles for effective integration. My job as president of the Infrastructure Commission is to make sure that this technology as a new tool, I mean, this is a new tool that we have in our truck, if I can use that analogy, is key. And in my view, those common principles are key for the interoperability and contingencies. So we may end up with a number of NMHSs and or regional consortia running different type of applications. But the key point is to have common principles that allow interoperability of those systems and the comparability of what is being generated by those systems. So I think this is really key. If we move to the next slide, Ian has alluded to it in terms of the light governance that is required, but I will insist on that because we simply cannot continue to work at the pace we are currently working. It's up to you members, and we do our best to try to follow the parade here. But the key will be in working faster. And it does not mean that we're not rigorous. It does not mean that we will not be extremely systematic about the way we approach those problems. But we need to find a way to work faster. And clearly, if we want to involve academia and the private sector, the key will be in putting in place the right framework to work faster while maintaining the rigor. Let's not forget that what we do is for public safety consideration first. Therefore, I would not recommend moving blindsided with new technologies without, proper common principle, proper verification protocol in place, and proper, value cycle approach to actually look into the problem, understand what's going on, and come up with technical solutions to further improve our systems. Last slide, please, and I will stop there. We talked about the joint advisory group that I will co-chair with Professor Lynch. We've already had some discussion. Everybody wants to be part of this, and we're limited to 20 to 25, full members to this. Rest reassured that, and I have already exchanged with Professor Lynch on that we will be making room, especially in the context of virtual discussion, to observers to the team. So I want to make sure that everybody can actually listen to the deliberation of the discussion, and we will figure a technical way to actually get the input from observers through monitoring of chats and things like that. So AI technology actually allows us to do that quite effectively. And others will likely build on the mechanism for collaboration, but again, it needs to be light, it needs to be able to work fast. And we're not starting from scratch, right? Dr. Rabier mentioned earlier, we have a framework which is called NMHSs. We have open source codes from public, private, academic institutions. We have something called Forecast in a Box, and there are other things as well available. So we have everything. The key point is to develop a framework and find ways to actually involve organizations like the Linux Foundations or other to actually support our efforts there. And Florence, I will get back to you, and I believe we can go to Owen Moran there. Thank you.
Thank you very much, Ian, and thank you very much, Michelle, and indeed thanks to the WMO for organising this wonderful panel discussion, and thanks to the WMO and our colleagues for organising the multiple conferences that have taken place over the last 12 months. And congratulations to Zhan Wei for Mazu and the good work with Ethiopia, and of course Roar and colleagues, and Lucy with the BRIES model and the Forecast in the Box and ECMWF. It really is inspirational. I'm going to be focusing on perhaps a few reflections and perspectives that were gathered during the conference, focusing on items that have already been touched on: data, governance, standards. We're familiar with this in this environment, but also ethics and responsible scaling, and how do we augment human expertise. It's certainly the case, as has already been mentioned, the AI revolution that we're seeing in front of our eyes offers a unique transformative opportunity to democratize what in reality is life-saving technology. So this is absolutely key for developing the capability of our least developed countries and partners within this organization and small island developing states. So this is a transformational opportunity for our partners in this space. Now, and progressing needs, as Michelle and Ian have mentioned, will be based upon now moving quickly, moving in an agile way, moving in new ways, changing and rethinking the way we make decisions. But this has to be based upon a set of common principles. And the conference statement that was agreed by those that were there sets that out. But the starting point is where there is due respect, full respect and recognition shown to the public mandate of national meteorological services and states to protect life and property. So it all builds from there. So our principles need to focus on protecting life and property, ensuring public trust. Our community and this organization, each one of us, have developed public trust with our citizens. And that's not something that happens overnight. It has to be maintained. And of course, ensuring, as this revolution takes place, that there is equitable enablement of access to forecasting capability and taking into account early warnings for all, there's a unique opportunity facing us. First of all, we need to look into the future as this technology starts scaling up and globally and regionally across consortia in ways that we cannot yet predict. There are a number of things we might consider, and these were discussed during the conference. The first are ethics, and perhaps there's a need to put in place common principles to guide responsible machine learning development and deployment. The reason this was raised because what was discussed and considered at the conference, as Ian was mentioning, was an open and honest discussion that's not just across multilateral boundaries, but also across sectoral boundaries. So what was discussed here was establishing and developing an ecosystem of partners right across the private sector, big tech, academia, and public sector organizations. And that requires an ethics set of principles, it is suggested. And this is to ensure that we have transparency, traceability, and accountability right across the full ecosystems in an interoperable way. This is to ensure the public can maintain trust in the forecasting systems and the forecasting warnings that we develop. So responsible scaling is absolutely key here. So we should consider the concept of perhaps exploring ethical governance to ensure responsible scaling occurs, because we are not the only actors now. We are not the only partners and stakeholders in this environment. Within the governance, under the governance heading, it's important as we start developing ecosystems right across sectors and within our multilateral community, that we understand that we have to explore the incentives, the interests, the strengths, weaknesses, and barriers of everyone within that ecosystem. And there are different dynamics, and it's important that we explore that and build any governance structure and engagement on those principles. In terms of technical standards, its open sourcing is completely central to enable traceability, verifiability, reproducibility of resources. There are multiple factors. We run operational systems that the public depend upon to protect life and property. So we have to, for example, be sure that we can sustainably mitigate market failures or some black swan event that might occur in the market. While at the same time, we have to ensure that we can foster collaboration and innovation right across the full ecosystem. So open sourcing, including weights and architecture and tuning data and labeling, was suggested to be a solution there. This was discussed. Then in terms of data, people have already talked about non-traditional data and the need to translate diverse data sources. So perhaps, and what was discussed was establishing a multi-content protocol and continuing to develop our data strategies in that way. Data provenance is absolutely key, as is model traceability, to be able to verify what was going on. And ultimately, this is about augmenting and supporting forecasters. The act of forecasting is a collective scientific endeavor and cannot happen on its own. And AI has to be developed to ensure that the knowledge-based process of forecasting is supported and augmented. It is not purely a robotic exercise, but it leverages expertise and contextual understanding, and that will remain vital, certainly for a while. So managing uncertainty and ensuring that our users have the deterministic answers that they seek from this chaotic, probabilistic system that we're trying to forecast is absolutely key. So that's a short summary. Thanks very much.
Thank you very much. So this closes the formal presentations that we will have on this panel. Now we will come to the questions. And this is the time to really hear your thoughts about either questions on what has been presented or a broader question. And I will let Nir maybe frame the main question we want to discuss today.
So Next slide. So the floor will be shortly open to all of you to comment, to ask, etc. But I think that the big question that we are around, which is, okay, we see the opportunity, how do we make it happen? So what do we need in order to have a widespread deployment of AI prediction system in the developing world by, let's say, 2030? I think this is a framework under which a lot of questions and a lot of interesting discussions could happen.
For you for questions or comments. Yes, Saudi Arabia.
شكرا جزيلا لإعطائي هذه الكلمة. في البداية أرغب في أن أشكر المنظمة العالمية للأرصاد وخاصة سكرتارية المنظمة على وضع مثل هذه الفعالية المهمة في جدول أعمال هذا المؤتمر الاستثنائي، وخاصة في فترة الصباح، لأنه فعلا هي الموضوع مهم جدا. اليوم أتحدث بصفتي رئيس الإقليم الثاني لآسيا، وأود أن أشير إلى بعض المسائل ذات صلة بمساعينا نحو التوجه الاستراتيجي للمنظمة العالمية للأرصاد الجوية في مجال الذكاء الاصطناعي سريع التطور، وأيضا مداخلتي هي تتعلق بما عرض في الشاشة من محاور. فأولا يتمثل التحدي الحاسم الماثل أمامنا في كيفية الاستفادة من هذه الفرصة، وكيف نسخر قوة هذا العصر الذكي ليس كغاية في حد ذاته، ولكن كأداة لا غنى عنها لحماية شعوبنا وتأمين مستقبل قادر على الصمود. ثانياً، أرى في حين أن الحماس للذكاء الاصطناعي كبير، إلا أنه لا تزال هناك تحديات أساسية تتمثل في العجز المستمر في البيانات، وإن أجزاء كبيرة من منطقتنا تفتقر إلى بيانات المراقبة الأساسية التي تعد الوقود الأساسي لأي نموذج ذكاء اصطناعي موثوق، ويتفاقم ذلك بسبب الفجوة الكبيرة في البنية التحتية الرقمية، والأهم من ذلك ندرة رأس المال البشري مع الخبرة المشتركة في الأرصاد الجوية وعلوم البيانات اللازمة لدفع هذا التحول. جهات رسمية في بلداننا نقوم بإخطار الجهات الحكومية الأخرى والمجتمعات بالإنذارات من الطقس الشديد وأيضا الظواهر الجوية الشديدة، فيجب أن نكون حذرين في استخدام التقنيات التي نستخدمها لهذه الأخطار. ثالثا، يجب أن يكون نهجنا هو بناء الذكاء الاصطناعي كشريك قوي وموثوق للخبرات البشرية، ومن ثم هناك حاجة إلى ضمان قوي للجودة، اختبارات صارمة قبل التنفيذ، وضع مبادئ توجيهية واضحة بالشراكة مع جميع أصحاب المصلحة بما في ذلك القطاع الخاص. رابعاً، من الأهمية التشديد على الحاجة إلى تعاون مكثف لتعزيز بياناتنا الأساسية وبناء القدرات بين جميع أعضاء المنظمة العالمية للأرصاد الجوية، وضمان وفاء هذه الثورة التكنولوجية بوعدها للجميع دون ترك أحد خلف الركب. أخيراً، قبل أن أختم كلمتي، أود أن أغتنم هذه الفرصة لأبلغ هذا التجمع الكريم بأننا نشهد في منطقتنا المتنوعة ضمن الإقليم الثاني آسيا تطوراً ديناميكياً ومبتكراً في مجال الذكاء الاصطناعي، لكنه في الوقت ذاته يشهد انقساماً عميقاً في مجال التقدم وتبني الذكاء الاصطناعي. نحن بالفعل موطن لرواد عالميين يضعون معايير جديدة للعالم بأسره، وليس لدي أدنى شك في أن هناك التزاماً واضحاً وعالياً بتسخير هذه التكنولوجيا للصالح العام، وإن أعضاء الإقليم الذين يملكون القدرات اللازمة مستعدون لمشاركة خبراتهم على نطاق واسع، ويتجلى ذلك في العرض الذي قدمته الأرصاد الصينية عن مازو في هذا المؤتمر الاستثنائي، وشكرا لكم وحسن اصطغائكم.
Thank you very much. Now going through the room, I can see Italy.
Yes, thank you. Good morning to all, and thank you to the panelists for the stimulating presentation, which gives us an idea of different applications of AI. And I'm sure that we do not have the depth on how broad, how wide is the application of artificial intelligence in different processes and for producing different products. I want just to pick up on words by Second Vice President Moran when he spoke about interagency approach and academics. Just to announce something that maybe you know about the next establishment of the 14th Institute of the UN University. The UN University has selected Bologna in Italy as the siege for the establishment of the 14th Institute, and this institute will deal with artificial intelligence. Therefore, in the spirit of interagency approach, cross-cutting collaboration, I do encourage, as soon as the Institute will be operational and as soon as the Institute will be ready with the staff, with the proper staffing process, to be involved in such processes and invite this community to be in contact with the Institute, which should be operational early next year. Thank you.
Thank you very much, and for this announcement of the UN University. I believe it's Uganda.
Thank you, Chair, and all the presenters for very clear presentations. The issues of AI need to be handled with a bit of caution. It's very clear that if you look at the presentations here and elsewhere, everybody is talking about improved quality of the forecast when AI is deployed. But it's important, as mentioned by, I think, the president or one of the presenters, that there's need for adequate validation and verification. Tests for suitability in a given region need to be undertaken. Having said that, I'm quite impressed, though, with the presentation from CMA on Mazu. And I've noted that it's already being deployed in a number of countries, including Ethiopia, Pakistan, and others. Being mindful of what we are observing in the region, our region, where we are seeing increasing frequency and intensity of extreme weather occurrences with devastating impacts. How easy is it, this question goes to CMA, how easy is it for members to work closely with CMA to have this Mazu validated, tested for suitability for deployment in our region? Thank you.
Okay, do you want to take the question?
Thank you very much for your wonderful questions. I think I have described some different versions of my platform in my slides already. For I think that the most efficient approach to achieve the running platforms is the cloud version. Cloud version is totally free of charge and directly available, accessible via internet. So I'd like to invite you to try the cloud version first online, and we will provide you some online training services. I also welcome all the users to give us some feedback and help us to improve the application of this platform for global users. And after that, I think based on the cooperation, we can explore some further approaches to deploy some localized versions of Mazu platform. Thank you.
Okay, thank you very much. I think Denmark has been waiting for the floor quite a while.
Whoa, now it works. Thank you so much. It's not so easy. Thank you very much, and thank you to all the presentations and all the knowledge you have delivered to us today. Personally, I'm really impressed by the improvements the whole society as such has done in a quite short period of time. So thank you for presenting all these things to us. I'll try now to answer the question which is on the screen. What does it look like towards 2030? What should we focus on? And many things could be focused on, but I'll pick up at least one comment from what was mentioned from the AI Conference, where I think it was you, Ian, commenting on the fact that if you look at the structures within, it could be nationally, could be regionally, could be globally, we are working within. They don't fit very well together with the demand for being able to take decisions fast. And I feel that on a daily basis in our institute, DMI, that we need to move much faster. We need to be able, as responsible decision makers, to take decisions much faster. And I really like to support how we could have a discussion more intense, how to get that, how do we manage to do that with being still able to hold the responsibility we have. And in that context, I would also like to mention that I really like us to talk about this as an ambition rather than a threat. Because when we just talk about this AI and ML development as a threat, it's a monster, it's something which is doing evil things to us, we will never get the support for those who are working in this sphere and our users. So I would really like to look into this as an ambition, as something which could bring us to somewhere where we would really like to go, which means a place where we are able to serve citizens of the globe in a much better way than we are today. That brings me to one of two questions. So one is, and that's part of what do we have to do before 2030? How do we get the meteorologists, the forecasters, the people, our members of staff, who are, what was also mentioned from the panel, the human element? How do we make them come on board? Basically, this is a threat. We can do everything faster and smarter. Usually that means that we need less capacity, less members of staff. So how do we find a language? How do we find a way of discussing things, which means that we have these people on board? It's really, really necessary. And my last question is, I paid attention to the fact that two of the presenters used the words that the AI and ML products are filling the gaps or closing the warning gaps. So what is the storytelling? Is the storytelling that we are going to have a completely new setup, get NWP buried and wave goodbye? Or But is the storytelling somehow different? That we have now methods which could fill in the gaps, as mentioned today, which are needed because NWP is lacking answers to difficult questions in a very short period of time in warning situations. And with that comes also the verification ghost. We have to be able to verify the warnings we do. So I think the things mentioned here are at least some of the things which I think about when you pose the question about what to do before now in 2030. Thank you very much.
Thank you very much. We're running out of time. I will take just a couple of more interventions, so please keep it short so that we can have as many as possible. And I will start with Curaçao and Saint Martin.
Thank you, Chair. And I would like to thank also WMO and also the presenters for today. Excellent presentation to highlight the different opportunities that we have for the AI, because we have a lot of opportunity. I will start by telling you that when I was training for a forecaster, we had to analyze the weather by hand. And nowadays the computer is doing it. So we're moving forward. And now what I'm seeing is, I think the president of the infrastructure have mentioned it, we have to take care of the value chain. And if we see the value chain of today, one forecaster is too much detail. He has to look at different models. There's about 10 models right now with 50 levels. You have satellites that have about 16 bands and a lot. So that's why right now is the opportunity that we will use the AI to help the forecaster do his job. Furthermore, if we are able to automate a smart way the whole value chain, it is important that the forecaster will stay as the authority to go through the proposed warning, and then it will validate it and it will issue that warning. And that is what I see for the future. Especially we in Curaçao are working together with a private company that is the data center BlueNep Americas, where together we start working on a concept, proof of concept, and there is where we're going to work with them. So we will be able to automate the value chain in a smart way that will provide at street level forecast, but also warnings. Thank you so much.
Thank you very much. Another good example of collaboration. Oman, please.
Yeah, thank you. Thank you very much and good morning, everyone. And I would like, first of all, to thank all presenters for their valuable participation, which reflects, in fact, the importance of AI in our daily forecast processes. And I would like also to thank you, the WMO Secretary, for their, which recognize the importance also of the AI topic. This is very important thing from WMO. And if we think strategically, I think we have right now, it's never late. We have strategic goal, which is the deployment of AI prediction systems in the developing world by 2030. What I would like to suggest here is to extend that date to 2035 to divide the goal or the strategy in two parts, two stages. We have 10 years vision on AI processes, and we need from now also to build action plan for the next 5 years. From the previous examples, to shrink ourselves in 5 years or 3 years will be very difficult also to deliver and to ensure the delivery of these new processes. For the action plan for the next 5 years should include also a correct plan, including plan conferences, workshops, platforms, how we can create a global platform from WMO to serve the least developed countries. We set some goals, indices for the next 5 years, and we set also for the next 10 years. So we need also to think strategically on this very important topic. It is never late. We can start from today, from these months, to create that vision. Thank you very much.
Thank you. And we only have a couple of minutes, so I will go to Switzerland, and I'm afraid I won't be able to take any more questions.
Okay. Thank you. I just would like to echo all the thanks for the presenter from China, Malawi, and Norway, and the other ones. It was excellent to hear that. And being at the conference, at the AI conference, I was also quite impressed about how important trust is in connection with AI. Trust is something that develops over time. Trust we need in the AI forecasting and in the AI warning, and we need to be very careful that this one is really established. And I think a network like WMO helps to have this trust, because it's international community that helps to build up the trust that the people living in the street and deciding and have to act really need. And in this sense, coming back to the question, here is written, what do we need in order to have a widespread development? I would suggest that the question should be, what do we need in order to have a widespread coordinated development? We need to be careful that we do a coordination among us in order to have a strong development. So my question to the WMO, to the podium, is actually, what can WMO do to really ensure and make a force coordination of these developments, in particular in the developing world? Thank you.
Maybe we need another hour or so to answer the question.
Only 1 hour.
Well, I think this discussion will actually help WMO think further about how to organize itself. I've seen the Secretariat take a lot of notes from all your interventions, but I'm afraid I've been given 5 minutes more from 10:30, and I will have to close it there. So thank you very much to all the presenters, to all the members for the very lively discussion. It's obvious that there's a lot of interest in the topic, and we've heard a lot of key words about we need data. Data is absolutely essential in our field. We need a fast pace, but we heard as well that it's not so easy to work so fast. We need to keep rigor while going fast, and we need trust. And more than ever, we need collaboration. So we will reflect on that, and I'm sure that AI in its working group and its strategy will develop, taking all that into account. So just to remind you that Met Norway and Malawi are going to have a little demonstration outside the room. So don't miss it. And in the meantime, thank you very much for a very interesting panel. Thank you.
Sorry, everyone. While we change the podium, we will be playing a small video on AI, so you can take note of it while we move forward.
In the last couple of years, artificial intelligence has been used to advance numerical forecasting. And with the rapid advancement of technology, the growing technology in the last couple of years, helped to advance the application of artificial intelligence in weather forecasting.
This is a very new field,
but it's shifting us from a regime where we're using physical models that are modeling the actual physics in the atmosphere to predict the weather, to one where we're learning from the data, we're learning from our existing data about the atmosphere to be able to predict the weather instead. And this brings with it enormous advantages. Now, because these AI models are more affordable, it gives them the opportunity to be able to run their own models in-house, which is very important for national sovereignty. And it also enables them to really focus